Okay, so now we're going to finish up measured numbers. We're going to look at rounding off numbers. So we're going to look at the rules for rounding off numbers. Again, with this, keep this handy. If you can print the slide out or mark it in your text, whatever, because these are going to become very, very important as we move through the course. Use only the most significant drop digit to decide how to round off. The rules for rounding off are 1. If the most significant digit dropped is greater than 5, or a 5 is followed by any non-zero digits, increase the last retained digit by 1. If the most significant digit dropped is less than 5, do not change the last retained digit. And finally, if the most significant digit dropped is 5, and there are no following non-zero digits, increase the last retained digit by 1 if it makes the number even. If it makes the number odd, do not change the retained digit. This is called the round to even rule. Okay, and you'll see these round off rules presented in different ways in different courses, but this is the way your author likes you to use the round off. So again, looking at examples, round the following numbers to 3 significant digits. So we've got, I don't know, half a dozen examples here. So we're going to look at them individually. So if we look at 10.071, we can round it off to 3 digits by 1 doesn't change 7, but 7 changes 0 to 1. So you have 10.1. 29.961 rounds all the way up to 30, and you can take it one at a time. 1 does not round 6, but 6 rounds 9, 9 rounds 9, and that 9 rounds to 30. So it rounds all the way up to 30. So you can see in error and accuracy, you've got some accuracy things there that you might have to tend to when you're doing other calculations in determining what the round off error is and what your accuracy is. 6.3948 then rounds to 6.39. So 8 rounds 4 to 5, 5 rounds 9 to the value of 9, okay, because we've got an even number, and then 3. So the 4 and the 8 become insignificant for the rounding. 123.5, the 5 rounds the 3 to 4. 122.5 will round to 122 because 5 or less rounds down. 328.52 rounds to 3.29. 2 doesn't affect the 5, but 5 will round 8 to a 9. So in most electrical and electronics work, components have tolerances greater than 1%. 5% or 10% is actually common, and we'll see this especially in resistors. Most measuring instruments have accuracy specifications better than this, but it's unusual for measurements to be made with higher accuracy than 1 part in 1,000. For this reason, 3 significant digits are appropriate for numbers that represent measured quantities in all but the most exacting work. If you're working with a problem with several intermediate steps, keep all digits in your calculator, but round the answers to 3 when reporting a result. So it's okay to enter every one of the digits, and let the calculator handle it. But when you're done, look at the number and make a determination if you need to round up or down to 3. So in this chapter then, and in this section, measured numbers, we've had lots of key terms that we need to keep in the forefront of our mind as we're dealing with accuracies, error, and significant digits. Accuracy, engineering notation, error, dealing with exponents, dealing with metric prefixes and powers of 10. What's the precision? How do we round off? Looking at scientific notation and knowing that engineering notation is a subset of scientific notation. What is a standardized SI unit? And what are the significant digits? So that wraps up chapter 1 of your text, where we deal with quantities and units. So in the next installment, we will look at how we deal with voltage, current, and resistance in chapter 2.